is Mircea Florin Bailan. I will present a part of our research activity that is realized in Romania. Florin Claudiu Pop is my PhD student that practically is a co-author, and with my associate professor Marcel Kremer. In Romania, this research activity will be integrated as a service in a dynamic adaptability system that we develop now with some other universities from Europe, as University of Nice, Sofia Antipolis. The agenda will consider some elements that are on the screen now, and I will pass step by step by these elements. Part of these elements were presented in other sessions at this conference, and that's why I will pass maybe faster. Some elements about traditional learning versus e-learning were presented yesterday, today in the morning, and they are not our research. They are presented on that website that is downstairs. We'll refer to classroom discussion, and it's important to know that in a traditional learning, usually the teacher talks more and the student don't want to talk. The learning process usually is realized with the whole class. Subject matter, usually if exists a curriculum, will be followed. Usually it is possible in some universities the teacher will decide that. It's important that, considering emphasis in the learning process, that students learn what and not how in the traditional learning, and in e-learning, how and less what. I not totally agree with this classification, but the student's motivation is low, usually, in traditional learning. It depends on the teacher. And if the teacher is not able to have, let's consider the students very close to him, they will be not motivated, and the teacher will be distant. The teacher is the authority, usually, not always. The activities in a classroom realized, and so on. Before to pass to the research, this slide will refer to alternative education and science spirituality education. Why this slide? This slide is because usually in the research activity we are interested only on technologies. And I think it's not sufficient. And I worked in research activities since the 70s, and now I am in academic, but I am involved in a lot of research activity. And this connection that must be established between student and teacher is very important. In this mode, a spiritual student is able to teach more and deeper, and if you are able to choose different technologies that are very important, we must consider also some techniques like brainstorming, like Enneagram technologies that I used and I presented in some papers. That's why in this mode the student will not be a robot, will be a human that will work with technologies and with good results. Usually in the university learning system, we have a lot of students, and what is important is that the background of students is very different, and they must work more if they want to be, let's consider, at the same level. About mobile computing and traditional learning, we understand that in this moment quite every student has a mobile device, a laptop, an intelligent mobile device with a webcam. And this activity will try to specify that using, let's consider, low-cost technologies, we are able to improve the education support. Why eye tracking? My research activity was oriented to image processing and pattern recognition. One of my last research activity was in automotive, practically in autonomous driving for a big car company in Europe, based on tracking using stereology. And in this mode, my PhD student explained me, okay, I want to use something like this in education. We are able, because 90% of people are visual peoples, to analyze the activity of the eye. Eye fixation, refixation, attention level are some parameters that we may consider in this process. The objective of our research was to offer highly available product, easy to be used, to deploy, to use the existing infrastructure, and is very important at a low cost. We proposed a solution based on two levels, a learning assistant level and a teaching assistant. The structure is this. Practically, the teaching assistant will offer the course support we may consider in different modes. The basic knowledge will be transferred to the learning assistant, or student. An eye tracking mechanism will be realized in this case. We determine the interest tracking. We consider in this case a knowledge processor. A statistical processor will realize the statistics, and if the interest was higher, we have an interactive knowledge that will offer supplementary information. It's important here to understand that from slides with text, the text regions and images are selected, and in this mode, longer focused on certain areas will determine the subject's interest. In the teaching assistant, it is important to know that the knowledge is split into smaller units. That means the text we associate semantics, and for images also the teacher will associate semantics. The eye tracking, considering an open source and a low cost, is implemented using machine perception toolbox from University of San Diego. And practically in this mode, we are able, considering 15 frames, 12 frames are sufficient, but usually for this example it's for 17 frames, to evaluate each frame and to establish the eye positions and the parameters that I specified. A region of interest will be determined for the eye region, and the result of the analysis is the fixation pattern. Here, practically, we are able to use, and we propose a scene tracking mechanism that will analyze the fixation for different text regions. Another variant is based on hotspot analysis that exists on the market. Here is an example that is specific. Practically, we establish a fixation count, and the first most focused element by the subject is considered the student's main interest. Supplementary information in this moment we offer considering Wikipedia. Wikipedia is easy to be accessed, offer open source information, and in this mode, if the student's interest is greater, we offer that like is specified here. The course management of the teacher is a classical one based on a Web 2.0 portal and an HTML format. Here is an example. The knowledge processor is the intelligent part of our system, as I specified. Will analyze the slides, will split into words, will associate semantics, and in the image we associate for image different description of semantics. The statistical processor will determine if there are a difficulty in following some aspects of the course. The teacher will be attentioned and will adapt the learning process. Here is an example of the statistical processor. The interactive knowledge is based by an internet agent, and in this case we use an HTML unit that is able to realize this as open source and in a good mode. The evaluation, practically in this moment, as I specified, this is a component that will offer a service inside a dynamic adaptation system for an ubiquitous computing research that we realized with University of Nice Sofia and Police. The test was realized on eMac, 24 inches. The courses were on our server, Windows 2003. Images and text not up to 30 words. Large fonts, considerable spacing between paragraphs. And what is important is that the feedback that the teacher gets from what the computer observes by tracking the student's eyes is a valuable source of information that allows to adapt the course in real time. It is important to understand that this research tries to center the education to student and to his interest. Another research that I developed with another PhD student that finished his PhD was based on mobile agents. It was an application concerning Java technologies, and practically in this case the course was offered concerning PDF files and were able to be integrated in education learning. I sent that to this conference, but they are not here specified. Thank you. I think I have about 10 minutes. And